All right, so we're going to do this derivatives of inverse functions activity, and this is meant to be more of a guided practice type activity that we would do in class together. But there's enough of it that is can be explained through direct instruction, especially once we get to the back, that I think it's worth having a video of it. So we're going to do derivatives of inverse functions at specific points, and before we get into that, we're going to kind of think about what an inverse is to start off with. Okay, so in Algebra 2, Algebra 1, you learned about inverses, and you learned about one-to-one functions. Okay, one-to-one functions are functions for which the inverse of it is also a function. Not all inverses are functions. Not all inverses pass the vertical line test. But one-to-one functions do have that characteristic for their inverse is a function. Okay, so if I told you that f of x was a one-to-one function and that 2, -4 was a point on that function, what point would have to be on its inverse? Sketch a one-to-one function that goes through the point 2, -4. Okay, so if 2, -4 is on the function, then on its inverse is the point -4, comma 2. Okay. Inverses are found by switching the x's and y's around. Every x and y coordinate gets changed around. And we can shortcut that if we're trying to find the inverse of an equation by switching the x's and y's in the equation and solving for the new y. That's probably how you learned to find inverse functions in earlier math classes. Okay, so we could plot the point -4, 2, 2, -4, so over 2, down 1, 2, 3, 4. And if it's a one-to-one function, its inverse has to pass a vertical line test. That means that this function has to pass the horizontal line test. Okay, so your function could look like anything as long as it passes the horizontal line test. That is, there's no place where you can draw a horizontal line through more than one point. Okay, so there we go. That's how an inverse is defined, how it's built. Let's go into this example here where we actually try to graph an inverse. Right now, the process for this, if we don't know what the function is and we just have some points, is we take all the points that we have and we exchange the x's and y's. So for example, we have 5, 4. That's going to switch to 4, 5. So we go over 4, up 5. We have pi 0, so we go to 0 pi. 0 and then a little bit above 3. All right. We have 0, 0, that flips to 0, 0. Doesn't really go anywhere. We have pi 0, that goes to 0, pi, so a little bit past -3 here. And then we have -7, -6.5, or -6.6. So we're going to flip that around to -6.6, comma -7, which puts us, let's see, -6.6, -7, down here-ish. Let's see, -7 right here. Okay. All right, and then you also might remember from your previous math classes that the graph of an inverse is reflected over the line y equals x. So if we draw in the line y equals x, we should get a perfect reflection over that line. And of course there's some variation based on how careful you are drawing your lines. Mine's off just a touch. Okay, so there's the line y equals x. All right, and then we can sketch that curve through there. Now, if you're like, I'm not really sure how these dots connect, how did you know what this looks like? Well, one thing that you can do is just plot more points. Right? If you're unsure what the inverse looks like based on the 5 points or 6 points or whatever that you have, just plot some more points, and then you'll be able to get a better picture. It's like playing connect the dots. You just need some more dots. All right, now the exploration is definitely an in-class thing, so we're going to leave that for now. I want to go to the back now and talk about the formula. Okay. Now there are 3 variations of this formula. They're all equivalent. And you can pick the one that fits your situation the most. I'll tell you what my favorite one is here in a minute. Okay. So the inverse derivative formula. If we're given AB is a point on the inverse, okay, that's super important. This point AB is on the inverse of F. Okay. Another way to say that is that F inverse of A is equal to B. Okay, so AB is a point on the inverse. If that is true, then all 3 of these formulas hold true. This one is read as the derivative of F inverse of A is equal to 1 over F prime of B. Equivalently, we could say F inverse prime of A. These are literally the same right here and here. They're the same, except different derivative notation here. And then finally, F inverse prime of A we can write that again, but then this formula, which I think is the most useful, and my personal favorite, is 1 over f prime of f inverse of a. And all that has been exchanged here is f inverse of a has replaced b. Okay, and that's what b is. B is f inverse of a. Okay. Special note here: if ab is on the inverse of f of x, then we know that ba is on f of x. Okay, half the battle in these problems is often just figuring out what is a and what is b. Once you get that, then usually you can plug stuff in to the formula and then get to your answer. But let's do a couple of these. Okay. So given this function, find the following. Now, this is a perfect example where the formula would be useful because sometimes students will say, why don't you just find the inverse function every time you need an inverse and then plug the value in to find the derivative? This is a spot where I'm not sure how we're going to find the inverse of this. If we change these all out for y's and then try to solve for y, that's a very difficult problem. Okay, so let's kind of identify what we're trying to find here. F inverse prime of negative 2. That's what we want to know. Okay. Now that means that I want to find 1 over f prime of f inverse of negative 2. Okay, I'm just following that third version of the formula there, and I'm plugged in negative 2 for a, because that is a, right? That's the place that we're trying to find the derivative at. Now, it would be very helpful if I knew what f inverse of negative 2 was, right? If I knew that, that'd be awesome. So the equivalent question would be to say, okay, you want to know what f inverse of negative 2 is? Solve this equation. Negative 2 equals, I don't really like how this kind of difficult to see. Negative 2 equals, all right, the function x to the 5th minus 4x cubed plus x minus 2. Okay, and solve that. Now, this one's, again, kind of tricky to solve, especially if you can't use your calculator, but you can maybe notice that this is negative 2 over here on the right. If you plugged in 0 for x here, then you would get negative 2. So the solution here is 0. So f of 0 happens to be negative 2, which means that f inverse of negative 2 is 0. Okay. So why is that helpful? Well, now we can take f inverse of negative 2 out, and we can write this, 1 divided by f prime of 0. Okay. Well, what's f prime of 0? Well, we could use your graphing calculator to figure this out, or we could derive it with the power rule, and then we could plug in 0. Either way, you get 1. So this ends up being 1 over 1, and that ends up being just 1. Okay. So I lay these three things out here and show you all the work here to show you that basically, like, if you can figure out these three values, you can answer any of these questions where you're finding the inverse at a point, the inverse of f at a point. All right. Let's do, I don't want to do all 6 in the video, but let's do, let's skip number 2. I'll leave that one for you to try. I will tell you that the answer is negative 1. So you can test that one and see if you can get to negative 1. All right. Let's go on to number 3 here. Number 3, this one I've not kind of given you the framework of all this stuff here. So you're just told, here's your function, find f inverse prime at negative pi over 2. Now I would start off the same way. I would say, okay, here's the thing that I want to know, f inverse prime of negative pi over 2. And then I would use that third variation of the formula there. Let's go to a finer tip pen here. So it'd be 1 over f prime of f inverse of this value right here, negative pi over 2. Negative pi over 2. Okay. So then you think to yourself, I'm going to need to do a little bit of scratch work here. All right. F inverse of negative pi over 2. What would that be? Right, because I'm trying to figure out this thing inside of f prime. If I can get that number, I can just find f prime of that number. So what would this be? Well, that is an equivalent question to asking you, what is negative pi over 2? And what is that equal to? Cosine of x minus x. Okay. All right, now this is something that's kind of difficult to solve algebraically. So what I would recommend doing, if I had to solve this equation and I could use my graphing calculator, I would graph the left-hand side and the right-hand side. So I'd put both of these in y equals. Y equals negative pi over 2. Y equals cosine x minus x. Graph them and find where they cross. That value where they intersect, that's the solution. And if you do that, you'll find that x equals pi over 2. Okay. So what does that mean? That means that in place of this f inverse of negative pi over 2, we're going to get 1 divided by f prime, and we're going to put in pi over 2 there. Okay. So then you ask yourself, well, what is f prime of pi over 2? And again, you could do this by hand, just derive the function and plug in pi over 2, or use your graphing calculator, figure out that it is negative 2. Okay. So you're going to get 1 over negative 2, or you could just say negative 1/2, like so. Okay. I want to do one example here. Let's do one where we can actually solve the function by hand. What's a good one? Let's do number 4. And then we'll call it good. I'll give you the answers for 5 and 6. You can go ahead and try those and check them. But I think we'll do number 4, and we'll call that good for the video here. So here I want f inverse prime of negative 1. Do the same thing that I've been doing, f inverse prime of negative 1. Rewrite that using my formula. That's 1 over f prime of f inverse of negative 1. Okay. And then I say to myself, well, I need to figure out what that f inverse of negative 1 is. So f inverse of negative 1. That is an equivalent question to saying what x value gives you negative 1 from that function, so 2 over x minus 2. And this one is pretty manageable to solve. Okay, so we can take both sides, multiply by x minus 2. X minus 2. And you're going to get negative 1 times x minus 2 here on the right, or on the left, excuse me, equals 2. Distribute, get negative x plus 2 equals 2. Finish out the math, and you get x equals 0. Okay. So that means that I want to know what is 1 over f prime of 0. Okay. Well, again, go to your calculator, figure out that f prime of 0 is equal to is negative 1/2, and so you end up with a negative 2 for your answer there. Sorry, going off the box there. But anyway, you get negative 2. Okay. So now would be a good time to pause the video and try 5 and 6. I'm going to give you the answers there. Okay, so hopefully you paused it and tried it, and let's see what you got. So for this one, f inverse prime of 2 is equal to positive 1/4. And for this one, f inverse prime of 1 is equal to negative 2. Okay? So give those, hopefully you gave those a try, and check your work, hopefully you got them right. If you have any questions, of course, just feel free to ask me in class. And that's it for the formula for derivatives of inverses at a specific point.